Hi, I'm Associate Professor Kenneth Low, the Program Leader for the 3 joint degree with Newcastle University, namely Marine Engineering, Naval Architecture, and Offshore Engineering. Allow me to share with you a bit of updates from the marine and offshore industry and also about the program. As you can see, Singapore is a global leader in the marine and offshore sector. For high-specification oil rig and offshore platform, Singapore commanded 50% of the world market. For conversions of FPSO, Singapore commanded 70% of the world market. And we also literally developed and built most of our entire fleet of Navy ships. The strength of our marine and offshore industry has also contributed to Singapore ranking as the #1 leading maritime capital of the world in 2019, and that's for 4 consecutive years. Some numbers for you. The total turnover of the industry runs at 11.1 billion Singapore dollar in 2019, and that's about 7.8% higher than the previous year. In terms of employment, we are looking at about 68,000 jobs. New orders secured reached 4.49 Singapore billion, which is 15% higher. The numbers of ships called in Singapore for repair total 2,652. So although it is 5% lower in terms of number, but in terms of total tonnage, it is 11.5% higher. And the numbers of vessels launched in Singapore total 64, which is 20.8% higher. But in terms of the tonnage, it is lower because the ships that they launch are of smaller size. The marine and offshore industry has also taken a serious look in terms of the transformation. How can we transform ourselves to better serve the global industry? So the vision is to achieve global leadership in smart marine and offshore engineering solution with optimized resource utilization. The roadmap is pretty straightforward. It is focusing on innovation, productivity improvement, and we have to continue to pursue new growth areas, and by equipping Singapore with the relevant skills. Our target for 2025 is to have a value add of 5.8 billion Singapore dollar and to add good jobs, and we're talking about 1,500 of those. One of the growth areas that I would like to bring to your attention is actually offshore wind. I'm very sure that all of you are very concerned about the climate, and this is in a way that we could contribute to the global climate change by reducing the reliance on fossil fuel. If you look at some of these key drivers over the past almost 15 years, looking for renewable energy, you can see that we have ventured into solar, we have looked at onshore wind, that means wind turbine that is on the shore side, hydro energy, and offshore wind. And the study shows that offshore wind has the largest potential. First of all, just to give you an example, in the UK, a 659 megawatt wind farm, offshore wind farm, could actually support 460,000 UK homes. That's incredible. And because it is actually offshore, it has very limited visual impact on the landscape, thereby making it attractive. So currently, Europe actually led the world in terms of offshore wind. And in terms of the country in specific, you can see that UK is actually leading the world with a huge install capacity, followed by Germany, and then followed by some countries in Asia. But you can see that primarily they are European countries. So my question to you is, can Asia be the next frontier for the offshore wind industry? And can Asia-Pacific region catch up with Europe? I believe the question is not if, but when. if you look at this chart on the global outlook, you can see that the European region will grow at a compound annual growth rate of about 8%. But in terms of APEX, we are looking at a staggering 26%. This is huge growth. And how do that translate into numbers? So if you look at the next chart on Asia Pacific, you can see that China, Taiwan is going to play a very important part in contributing to the installed capacity. Despite a slow start, we're expected to have a huge project being implemented in Asia Pacific. And in terms of where are these offshore wind farms installed, you can see at the middle of that gray box. So those are the high frequency. That means most of the offshore wind farm is actually installed primarily nearer to shore, because it's cheaper when it's nearer to shore, and also not in deep water. But you are beginning to see trends taken by both China and Taiwan, looking at installing wind farms that are further away from shore. So therefore, the technical requirement is going to be higher. And this is how Singapore can really play a part. And what are the future trends? You can see among this building, the wind turbine that is right in the middle is pretty big. It is almost as tall as the Eiffel Tower. So you can see this increase in capacity to about 12 megawatt. So just let you have a feel, 1 megawatt of capacity can usually power up to about 700 to 800 homes. So that's tremendous amount of potential for a 12 megawatt capacity wind turbine. But with that, you can also see that they are a lot bigger, and therefore, the infrastructure required to support this wind farm industry is going to be of more sophistication. In this next slide, you can see that the trends in wind turbine installation vessel, what we call WTI. So the trend is really moving towards heavier because both the blades, the turbine itself, and also the structures are all bigger. So that means you required vessels that have higher capacity to install such structures out in the sea. We are moving into deeper water, further offshore, and therefore there will be necessity to run the power line back to the shore. So more work are required. And as what I mentioned earlier on, the blades, just one blade can be about 110 meters. That's really, really huge. Right now, we are also moving into installation beyond 50-meter water depth. And that really required a lot of technical expertise. And you can see that the vessels for the installation of this wind turbine, they actually have a jacking system. And this actually plays into the strength of Singapore. For example, both Keppel and Sembcorp Marine, they have all this technology. In fact, it's proprietary to them. So talking about the jacking system, you can see that a very traditional jack-up rig, they move into position, they get jack up, and then they basically continue the drilling. They don't go through this jacking up and down. But for a WTI vessel, it's very different because the installation typically takes less than a week. So they have to be jacked up, and then they carry out the installation, and within a short period of time, they will have to unjack, and then they have to move to the next location. So there is a lot of research into the hydraulic jacking system, which again play into the strength of Singapore company. What about floating wind turbine? Singapore has been building a lot of semi-submersible platform. So this again is an interesting idea. That why not we just build floating wind farm? To support this, it is important for us to really look at how the university can introduce curriculum related to offshore wind. And we have made studies in the Netherlands, and in SIT and Newcastle University, we plan to introduce the wind curriculum into our second year and third year of our studies. As you can see over here, the offshore wind ecosystem is very complete and complex, from developing the site to the constructions of the offshore wind farm, and then followed by operations and maintenance. So there's actually a lot of work that is out there waiting for us. And in conclusion, for my sharing on the topic of offshore wind, I would like to say that the current offshore market is led by Europe, but Asia-Pac is the market of tomorrow. China is leading the way, with South Korea, Japan, and Taiwan following. And in China alone, more than 30 gigawatts of offshore wind is expected to come online through 2027. And new markets such as Australia, India, Thailand, and Vietnam will start within the next 5 years. So with this, I would like to now invite my industry partner, Mr. Kelvin Teo, Managing Director of Porsche Samco, to share industry perspective on offshore wind industry. Over to you, Kelvin.
Hi everyone, I'm Kelvin, the Managing Director for Renewables at Porsche. I'm currently based in Taiwan to oversee the new offshore wind business for the company. I'm very pleased to be here today to be able to share some of our experience in the offshore wind industry and how we have ventured into this new market. Over the past 14 years, I've been involved in the oil and gas business, taking on various commercial and business development portfolio in the company. I was previously the director of the offshore supply vessel division, managing over 50 vessels in Mexico, Africa, Middle East, and Asia Pacific, before moving on to take on the role of director for the business planning and projects to oversee the growth of new businesses and other overseas office. Prior to joining Porsche, I was dealing with various shipping lines and logistic companies at PSA Corporation upon returning to Singapore from my overseas studies, having received a scholarship from PSA. So some of you might be wondering, would it be possible for the world to be powered 100% by renewable energy? So I would like to share the slide that you see on the screen right now. See, in fact, there is one small island in Europe which has already achieved this milestone some 20 years ago. Samso, an island of Denmark, became the world's first 100% renewable energy power island in 2007. A total of 11 onshore wind turbines covered its electricity needs. A further 10 offshore turbines were installed thereafter, which compensated for the heat produced from non-renewable sources and private transportation. And the island is now 100% CO2 neutral. Of course, Samsung is a small island, which only has around 4,000 residents living there. And therefore, it might be a much easier journey towards 100% renewable energy. Nonetheless, the energy makeover for this small island took less than a decade and was spurred on by the local commitment by the resident, providing a good template for how the rest of the world could eventually transition to renewable. If you look at Denmark, offshore wind is already supplying up to 50% of their energy needs now. So I think we are not too far from this vision. So for some of you who are not so familiar with Porsche, we are a global solution provider for offshore energy with over 60 years of history. We operate a diversified fleet of around 100 vessels worldwide with 3 key business segments in oil and gas, offshore renewables, and subsea operations. We are a part of the larger core group, which is one of Asia's most diversified and dynamic multinational conglomerate. The group has diverse operations in various business segments like properties, hospitality, which is Shangri-La Hotel, it's part of the group, logistics, where we have carry logistics, media, maritime, commodities, and environment. So how did we enter into this new market? In August 2018, we formed a joint venture called Porsche Carry Renewables, together with Carry Logistics in Taiwan. Carry TJ Logistics is one of the leading logistic service provider in Taiwan, with over 6,000 local employees and listed in the Taiwan Stock Exchange. I recruited our very first local staff on 1st November and have since assembled a group of young and passionate local Taiwanese team at the Porsche Carry office, plus around 100 Taiwanese crew who are working on board our vessels now. It has been a very exciting journey so far, but full of challenges on the ground, as Taiwan is trying to achieve in 5 to 7 years in offshore wind what Europe has achieved in 30 years with no established offshore supply chain in Taiwan. Within the short 1 to 2 years of venturing into this new market, we have successfully redeployed some of the existing offshore vessels from Porsche from the oil and gas market into the offshore wind market in Taiwan, and also secured projects in all the 4 new wind farms in Taiwan. So what is our value proposition in Taiwan? If you look at the ecosystem for the offshore wind market, I think we do have various companies and businesses within the group which have the relevant expertise where we could offer customized solution to the wind clients. For example, our shipyard, Pac Ocean, have been working on various opportunity in the fabrication of foundations, offshore substation, mooring structure for the floating wind farm, or specialized wind farm vessel like the customized SOV design or turbine installation vessel, where they are currently building one new TIV for a client in the Japan. So that's for upcoming offshore wind farm in Japan. Our shipping line, PAC, they are not new to the wind business too. They have been performing various transportation projects of wind towers and blades for the smaller onshore wind farm. Porsche is already involved in this new business via the setup in Taiwan, and we are also actively exploring new markets and services at the moment, with an eye on the floating wind farm, which will be up and coming in the near future. Other sister companies within the group includes Carry Logistics, where they are already working on onshore logistics requirement for the various wind clients in Vietnam. Collectively, our aim is to bring together our deep experience in offshore marine, shipping, onshore logistics, and engineering and fabrication, and target to be an unique one-stop solution provider in this new offshore renewable space. How can Singapore companies play a key role in this new market? You see, over the years, there are many marine and offshore companies in Singapore which have built up world-class engineering capabilities and have done very well. They became global leaders in the oil and gas industry. Example, Keppel and Sembcorp. This shows that Singapore shipyards do have the relevant capabilities to capture various segments of the value chain in the new offshore wind industry too. Examples in the fabrication of substation, foundation, turbines, towers, and support vessel, etc. If you look at Keppel and Sembcorp, they have successfully secured over 1 billion US worth of offshore wind related projects in 2019. Penguin Shipyard, which specializes in aluminum vessel, has also delivered new crew transfer vessels for operation in the offshore wind farm in Taiwan and Europe. Of course, our Pac Ocean, which is a sister company to Porsche, has also secured a new shipbuilding contract to construct a new wind turbine installation vessel for a client in Japan. Amongst all the offshore vessel owners in Singapore, apart from Porsche, we have also seen some of them venturing successfully into Taiwan. They have set up office, they have deployed the vessels to the market. So I think this is a very, very encouraging sign. It's endorsement by clients in the offshore wind industry, where they recognize the deep expertise and global experience of Singapore O&M companies and are willing to engage them in various segments of this new industry. So going forward, as we see development in other new offshore wind markets in Asia, like Japan, Korea, and Vietnam, starting to accelerate, I believe there will be many more new opportunities for companies in the Singapore marine and offshore industry to move in and be in a good position to support the construction, operations, and maintenance of this new exciting offshore wind market. If you look at Singapore, we do not have any natural oil and gas reserves. However, that did not stop many of the Singapore companies from becoming global leaders in the various segments of the oil and gas industry. Similarly, for the offshore wind industry, I think many of these companies can also transition successfully into this new market and do very well in their respective segment. Once again, I hope that my sharing today has provided you with some useful insight on the offshore wind industry. Last but not least, I would like to thank Professor Kenneth for inviting me today to share on this topic. And I wish you all the best in your pursuit of undergrad studies at SIT. Thank you.
Thank you, Kelvin. So as you can see, it's very interesting and exciting to be in this industry. So besides the traditional marine and offshore, we also have new areas such as offshore wind. So how are we responding to the needs of the industry? So back in 2017, SIT and Newcastle University launched 3 joint marine degree programs in order to support the industry. And currently, we are glad to report to you that we have about 230 students across various years of studies. Allow me to take you through the academic structure and curriculum. We run on the full 3-year degree program with possible module exemption. And as you can see, we have actually an industry advisory committee that is actually set up to help us sharpen the curriculum and to also review the graduate quality for future industry. And these are CEO of major marine and offshore companies. We also collaborate very closely with Classification Society, thereby knowing the regulations, especially regulations on emissions, regulations for energy efficiencies and safety. And we also work very closely with the 2 professional bodies, namely the Royal Institute of Naval Architecture and the Institute of Marine Engineer Science and Technology for the accreditation of this 3-degree program. And we also make sure that our students are members of these 2 professional bodies. You can see that the academic structure is a bit unique compared to the other university. We run on a 3-trimester system. So in a year, we're going to run trimester 1, 2, and 3, starting from September until the August of the following year. And each trimester will consist of about 15 weeks, so about 12 weeks of classes, 1 week of midterm recess, what we call a break, and 2 weeks of final exam. And you get to have 2 to 3 weeks of break. A very unique proposition by SIT is 26 weeks of IWSP, what we call the Integrated Work Study Program, where you will spend time in the company and industry to really apply what you have learned from the university. And we also included this overseas immersion program where you will spend 3 weeks at Newcastle University, UK. And this is one of the highlights of the program. In terms of the curriculum, you can see that the first year, all the students from the 3 marine program will go through a common modules. So they will be touching on very fundamental modules such as material, mechanics, math, naval architecture, and marine engineering. And in the year 2, they will start to move into their core curriculum. And this is where they will move into a higher level of math, which we call analytical methods in marine technology, a higher level of marine engineering, and then they will also look at propulsion, marine electrical engineering, and dynamics. So this is where they will start to have a bit of differentiation between the marine engineers and the naval arch and offshore engineers. And this is also the time whereby you will go for your OIP, which is the Overseas Immersion Program, and followed by your IWSP. In the final year, you will finish off your IWSP, and you will kickstart with your capstone project, and followed by the specialized module. So example, for a naval arch, you will probably be doing a capstone project related to ship design. For your ship design module, you probably look at structure design or optimization. And this is an exciting year because this is where you could put all that you have learned into the capstone project. At the end of the day, we will expect you to reach 180 credit in order for you to graduate. So you may be wondering, is this the best curriculum? So let me assure you, they have been vetted by industry, and letters of support from industry and association has been provided to both SIT and Newcastle University. So you can be assured. As what I mentioned earlier on, our Industry Advisory Committee, the committee is led by Mr. Wong Wing Sun. He is the CEO of Samcorp Marine, and then Vice Chair by Mr. Chris Ong, the CEO of Keppel Offshore and Marine. On the OIP, I just want to highlight that it is really an experience. So for 3 weeks, you will be spending time not only with your marine classmate, but also with the students from other joint degree program between SIT and Newcastle University. You will work on group projects, and you will also visit the laboratory facilities and also industry based in the UK. As you can see over here, our students get to visit their research vessel. So they took a ride. And this is really interesting. This is one of the highlights that they told me. On Integrated Work Study Program, you are expected to spend 26 weeks with the company. And please take note, this is credit bearing, and they are graded. So it's really important for you to really select the right company so that you could perform. And we go through an interview system, so you don't get assigned to the company, but rather you apply. You go through interview, and if you are selected, you also decide whether should you take the offer. So this is as real as it can be. You can see that our students spend time in company ranging from diving support company to PSA Marine, and you can see that they are really having a good time. Very hands-on kind of IWSP. Not just the theory, but also the practical aspect. You may be wondering, during the 26 weeks, do they come back to the campus? They do. And this is where we will organize workshops to further enhance their skills. And there is this very important poster day where the students are expected to bring back good ideas from the company to be presented on this particular day. What about scholarship? There are many scholarships that SIT and industry partners are offering, but I just thought I want to highlight this achievement. In 2019, 7 of our students, they were awarded the SMF, Maritime One Scholarship, a very prestigious scholarship. And I think this is actually in recognition of the standard that we have arrived, even within this very short time. And achievement from the seniors. So our student participated in 2 major competitions. First is actually a national level competition on the low-cost LNG retrofit challenge 2019. And 2 of our student groups actually won the commendation award. In fact, out of 3 prizes, we won the top 2. So you can see that they also work closely with industry, with Sembcorp, rather than just by themselves. So it's not just a paper exercise. They really spend time going up to LNG tanker, going up to vessels to investigate if they could retrofit vessels for LNG application. And this is another group that also won the award. Another competition is the ferry design competition, which our 3rd-year student actually won the top prize. So this is a ferry that basically will be able to rely on solar energy, and at the same time, they are able to clean up the debris left in the rivers. So they actually won in terms of both concept and also innovation. What about our graduates? So you can see the class of 2019, they have already graduated in 2019, and they have actually achieved 100% employment. I would like to share with you. In fact, one of my last students, she just got employed, just last week. In the class of 2020, which just graduated in October 2020, we are wishing them all the best. So they are out there looking for jobs, and I'm very sure that they will definitely be able to secure good jobs. You can take a look at their graduations, all happy and smiling, and I think they really deserve, the celebration. So with this, I would like to end my presentation, and I would really like to encourage you to consider carefully and do join us in SIT and Newcastle University for the 3 Marine program. Thank you for your time.